So the chlorine is present in this carbon atom, which is adjacent to a carbon atom which is a part of double bond. So this carbon atom is called as the allylic carbon and this is called as an allylic halide. So where is the bromine atom present? The next one, it is present in the meta position corresponding to this one. So it is also called as meta dibromobenzene. The question can be, what is Lucas reagent? So you need to know what is Lucas reagent, and question can be, which reagent is used in preparation of haloalkanes from alcohols. Hello everyone, this is Ambli Unnikrishan from the Department of Chemistry. So today we are back with session 2 of the chapter Haloalkanes and Haloarenes. So in the last session, we introduced what is haloalkanes and haloarenes, right? Yes, and then we studied about the different classification. First, we discussed the classification of monohalogen compounds, right? And then compounds containing sp3 carbon halogen bond as well as sp2 carbon halogen bond, right? And the classification of dihaloalkanes also. What is vicinal dihalides and what are geminal dihalides? All of this we discussed in the last session. So in today's session, we are going to study about nomenclature of haloalkanes and haloarenes. So in class 11 itself, you have studied the basics of nomenclature, that is IUPAC nomenclature of organic compounds. So based on that itself, we are going to study about the nomenclature in haloalkanes and haloarenes, right? And the nature of the carbon halogen bond as well as the methods of preparation of haloalkanes we'll be studying in this session, okay? So to begin with the nomenclature. So the common name of alkyl halides is obtained by adding yl halide to the word root plus yl halide. So that is how it will be. So it means that any haloalkane or haloarene will have a common name as well as IUPAC name, right? So how can we write the common name is written here? That means to the word root we have to end it by yl halide. So for an example, we can take CH3, CH2, Cl. Okay, so common name, how do we write? That is, it is obtained by adding yl halide to the word root. So that means it is named as ethyl chloride. So what is the word root here? It is eth, right? Okay. That is why, because there are two carbon atoms. Two carbon atoms means word root will be eth, right? And we have to add yl halide. So it will be ethyl halide. This is how we name the common name. Okay. So but our importance is to learn the IUPAC nomenclature, and the IUPAC name is obtained by adding the prefix halo to the name of the parent alkane. So we have to name the parent alkane, okay, and the prefix will be halo. So that is general. Halo is general. So in this example, as you can see, CH3, CH2, Cl. Okay, how is this haloalkane obtained? It is from which alkane we have obtained this 2 carbon containing alkane, CH3, CH3, which is ethane, right? So from ethane, one hydrogen atom is being replaced by another chlorine atom. So how do we write the IUPAC name? First we have to write the prefix halo. So which is the halogen atom here? It is chlorine. So what will come there? Chloro. Yes, chloro, and which is the parent alkane name? It is ethane, chloroethane. So common name will be ethyl chloride and IUPAC name will be chloroethane. Let's move on to the next example, CH3, CHBr, CH3. Okay, so the common name is isopropyl bromide or secondary propyl bromide. So as you can see here, on the second carbon atom, you have a bromine. So this is called as isopropyl or secondary propyl bromide. In the same way what we have written here. As you can see here, it should be yl halide, right? To the root word, we have to attach that. So that is why isopropyl or secondary propyl bromide you can name it. Okay. Why? Because to the second carbon atom, the bromine is being attached, right? And how would you write the IUPAC nomenclature? What will be the IUPAC name? As you can see, the bromine is attached in the second carbon atom. So we can number from either of the direction, it will be same because there are only 3 carbon atoms. So 3 carbon atoms mean which is the parent alkane here? It will be, yes, propane, right? And on which carbon atom you have the halogen group? It is on the second carbon atom. So that will come as the prefix. So it's not just writing bromo. On which carbon atom is the bromine present is also to be mentioned. So it will be 2-bromo propane. I hope it is clear. Moving on to the next one, we have an alkene here, right? A double bond is present here. CH2 double bond CH, CH2 Cl. Okay. So as you can see here, the common name is allyl chloride. Now what is this allyl? Allylic carbon, allylic halide. We have already studied this. So as you can see here, I'll expand it and write CH2 double bond CH, CH2 Cl. Okay, so the chlorine is present in this carbon atom, which is adjacent to a carbon atom which is a part of double bond. So this carbon atom is called as the allylic carbon and this is called as an allylic halide. Okay, allylic haloalkane. So I hope it is clear. Okay, so that is why it is called as allyl chloride. The word allyl is used because the chlorine atom is attached to the carbon which is adjacent to a carbon which is a part of a double bond. Clear? So how do we write the IUPAC name for this? Now it is not an alkane, it is an alkene which is present. So again, let's take this expansion itself. So here we have a double bond here as well as the branch is present here. That means to the third carbon atom, a chlorine atom is attached. So, do I have to number from this side or this side? We have to number from this side, right? Because the double bond will be having more priority than the halogen atom. Okay. So, now again, haloalkane, that is a format we have to write. Okay. So, which halogen is present? It is chloro. On which carbon atom? Third carbon atom. So, we write 3-chloro. And what is the parent chain name? It is propene, right? It is propene. On the first carbon atom, the double bond is present. So, we can just write it as propene or else we can also write it as prop1E. Clear? Now, moving on to the next one, which is an example of a haloarene. So, you can see a benzene ring here. One CH3 group is present. One Cl and another Cl. So, there are 2 chloro, that is 2 chlorine atoms and 1 methyl group is also present, right? So, now in this case, we have already studied in class 11 that according to IUPAC nomenclature, if many constituents are present, they have to be named according to their, yes, alphabetical order. So, you have CH3 which is called as methyl as well as Cl which is called as chloro, right? So, will chloro come first or methyl come first? Of course, chloro should be named first because that will come under, according to the alphabetical order, that will come first. So, on which all positions the chloro is present? So, of course, according to the alphabetical order, chloro will come first, right? But from where do I start numbering this constituent, different constituent? Should I start numbering from here or here? When we consider methyl and chloro, methyl will be having more priority. So, it will be numbered as 1, 2, 3, 4, 5 and 6. Okay. So, according to alphabetical order, chloro has to be prefixed first. So, on which all positions chloro is present? 2 and 4 position. So, it is written 2,4-dichloro. So, this di is also very, very important because there are 2 chloro atoms, right? So, 2,4-dichloro and you can write methyl benzene. Okay, 1 methyl benzene, or on a benzene ring, if you have a methyl group, it is called as, yes, it is called as toluene. It is called as toluene. Right, okay, that is this particular compound, that is a benzene with a methyl group, it is called as toluene. So, we can write 2,4-dichlorotoluene, okay, or else this is the common name, toluene is the common name which is given, but if you have to write the IUPAC name, it will be 2,4-dichloro and this methyl should be also written, that is methyl benzene. Right, methyl is also a constituent present. So, 2,4-dichloro, then we write methyl and which is the parent chain, it is benzene. Okay, so I hope it is clear. Now, moving on to the next one, CH3, CH2, CHCl, CH3. So, we can expand it and write it as CH3, CH2, CHCl and CH3. Okay, so the common name, it is secondary butyl chloride. Now, why it is secondary? As you can see, it is present on the second carbon atom. So, what is the common name? It is secondary butyl chloride. Why it is butyl chloride? There are 4 carbon atoms. So, from which direction I have to number? The chloro has to, that is the constituent or the branches should get the least number of, while numbering it should get the least number. So, if I start from here 1, 2, 3. And if I start from there, it will be 1, 2. So, hence I start numbering in this direction. Okay. So, the common name is secondary butyl chloride. Okay. And IUPAC name, it has to be written as haloalkane, right? So, the halogen is present on the second carbon atom. So, it is 2-chloro, and what is the parent chain? It is 4-number carbon, so it is butane. So it is 2-chlorobutane. I hope it is clear. Moving on to the next one, CH3 thrice C CH2Cl. So CH3 thrice Cl means to this carbon atom 3 CH3 groups are attached, right? And to which a CH2Cl is present. Okay. So if a carbon atom is surrounded by another 4 carbon atoms, this particular carbon atom is surrounded by another 4 carbon atoms, right? Hence the name is neo. Okay. If it is surrounded by 4 other carbon atoms, we call it as neo. And how many carbon atoms are there in total? There are a total of 5 carbon atoms. So it will become pentyl chloride, neo-pentyl chloride. Now coming on to the IUPAC nomenclature. So let me write it in this format: CH3, 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 CH2Cl. So here if you are going to number it, from which direction we have to number? From this direction we have to number, right? So from here we start numbering 1, 2, 3. So once we are done with the numbering, chloro or methyl comes first. Chloro comes first in the alphabetical order. So 1 chloro, 2, 2 dimethyl. So 1 to the second carbon atom, 1 methyl group is there, another methyl group is there. So it becomes 2, 2 dimethyl, right? 2, 2 dimethyl, and which is the principal chain here? It is 1, 2, 3 carbon atom. So it is propane. So I hope it is clear. The next one is CH3 thrice CBr. So it is CH3 thrice. To this particular carbon atom, 1 CH3, second one, third one, and fourth is a Br group. So surrounded by 3 carbon atoms, that means in a single chain 2 carbon atoms are present as branches. Okay, see these 2 are present as branches in this, right? So then it is called as a tert butyl bromide. The word is tert, and how many carbon atoms are there? Total 4. So it is butyl. Okay, it is butyl bromide, which is the halogen, bromine, right? So it is bromide. That is a common name. So how do we write the IUPAC name here? As you can see here, see which is the principal chain. Now we have to calculate. We have to see that which is the principal chain. How do we calculate the principal chain? Which is having the highest number of carbon atoms. So as you can see here, it will be 1, 2 and 3. So this is how we number it, 1, 2, 3. So on the second carbon atom, you have a methyl as well as bromine atom, right? So what will be the name? It will be 2-bromo, 2-methyl propane. So bromo is there, methyl is there. Again, according to alphabetical order, bromo comes first. So on the second carbon atom, bromo is there. So 2-bromo. And second carbon atom, methyl is also there. So 2-methyl, and which is the principal chain? It is propane. Okay, so 2-bromo, 2-methyl propane. Moving on to the next one, CH2 double bond CHCl. Okay, CH2 double bond CHCl. So the common name is vinyl chloride. It is called as vinyl chloride. And what is the IUPAC name? Chloroethane. Now what is the IUPAC name? It will be chloroethene. Now why it is chloroethene? Only 2 carbon atoms are present, right? So the chlorine atom is present in the first carbon atom. So it is chloroethene. Okay, the principal chain is ethene here. Moving on to the next one, CH2Br. It is called as, the common name is allyl bromide, and the IUPAC name, as you can see here, 1, 2, 3. The third carbon atom is having the bromo, so it is 3-bromo propane. Moving on to the next one, as you can see, a benzene ring is there, chloro as well as methyl is there. So which will come first? According to the alphabetical order, we have to name the chloro first, right? Okay, so as I told you before, benzene ring with the methyl group is called as toluene. Okay, so if this is the toluene, this is the first carbon atom, and in the order, this will be named as the numbered as the second one, right? So according to the common name, we can name it as orthochlorotoluene. So this position, considering this particular carbon atom, this position and this position is called as ortho position. These 2 positions are called as meta position, and the direct opposite position is called as para position. So instead of number, we can use ortho, meta or para in case of common names. So we can also name it as orthochlorotoluene. It is in the ortho position, right? Chlorine atom. So orthochlorotoluene. Now how will we use the IUPAC nomenclature here? On which carbon atom chloro is present? Second carbon atom, right? So 2-chloro we will write first. And on the first carbon atom, you have methyl. So 2-chloro-methyl benzene, right? 2-chloro, 2-methyl benzene. So I hope it is clear, right? So you can name it as 2-chlorotoluene or 2-chloromethyl benzene. Okay, now moving on to the next one. On a benzene ring you have CH2Cl. So what is this type of haloarene called as? Benzene ring is present here, the halogen is present here, which is attached to a carbon atom which is further attached to a benzene group. It is called as benzyl halide, right? So which is the halogen present here? It is a chlorine, so it is called as benzyl chloride. Now what will be the IUPAC name here? It will be chlorophenyl methane. Chlorophenyl methane. Now why it is called chlorophenyl methane? See, CH2Cl is here. So the parent chain was actually CH4, that is methane, from which one hydrogen atom was removed and substituted by a chlorine. Another hydrogen atom is removed and you have a benzene ring. Okay, so when the benzene ring is present as a substituent there, we call it as phenyl, not benzene. Okay, so that is why you have chloro and phenyl, then the parent chain is methane. Okay, so I hope it is clear. Moving on to the next one, CH2Cl2. CH2Cl2, the common name is methylene chloride. It is called as methylene chloride. And what will be the IUPAC name? It will be dichloromethane. Okay, why dichloromethane? Initially the parent chain is CH4, from which two hydrogen atoms are replaced by chlorine atoms. So it is CH2Cl2. How many chlorine are there? 2 chlorine are there. Is it necessary to mention the positions? No, because there is only one carbon atom. So it is dichloromethane. Now to this again one more hydrogen is replaced, CHCl3. The common name is very common thing that you already know. It is called as chloroform. So now you know the molecular formula for chloroform. It is CHCl3. So if CH2Cl2 is called as dichloromethane, then IUPAC name of CHCl3 will be trichloromethane, right? It will be trichloromethane. Now what will be CHBr thrice then? CHBr3 then? Yes, it will be tribromomethane. IUPAC name will be tribromomethane and the common name is bromoform. CHCl3 is chloroform, CHBr3 is bromoform. Now CCl4, all the hydrogen atoms in methane are replaced by chlorine atoms. Then what will be the IUPAC name? It was dibromomethane, tribromomethane. Now what will be this? Tetrachloromethane, right? Tetrachloromethane. All the hydrogen atoms are replaced by chlorine and it is called as carbon tetrachloride. The common name is called as carbon tetrachloride. Carbon tetrachloride. See, Cl4, right? So carbon tetrachloride. Now the next one is CH3, CH2, CH2F. That is on from which direction will number? 1, 2, 3. Okay, so IUPAC name will be, yes, on which carbon atom fluorine is present? First carbon atom. So it will be 1-fluoro, and which is the principal chain? It is propane, 1-fluoropropane. And the common name will be N-propyl fluoride, right? Propyl fluoride. Okay, now the next one is, it is simple. On the benzene, you have a bromine atom. So this is called as IUPAC nomenclature will be bromobenzene, right? Bromobenzene, and the common name will be also bromobenzene. The next one is, yes, here also you have a bromobenzene itself, but there are two bromine atoms present. Okay, so now we can number it as 1, 2, 3, or else we can number it in the opposite direction also. If you start it as 1, 2, 3, it will come. So both of the substituents should get the least number. Okay, so according to IUPAC, how will we number it? On two positions we have bromo, that is first and third. So 1, 3. So 2 are there, so dibromo, and which is the principal chain? It is benzene. So it is 1, 3 dibromobenzene. Now according to the common name, we already discussed ortho, para, meta is there. So if this is the bromine, this is the carbon atom, these two are the ortho positions, these two are the meta position, and this is the para position. So where is the bromine atom present? The next one, it is present in the meta position corresponding to this one. So it is also called as meta dibromobenzene. Meta dibromo, they are in meta positions to each other. Now you have 3 bromine atoms here. Okay, so what will be the IUPAC name? Let's number from here: 1, 2, 3, 4, 5 and 6. So you have 1, 3, 5, 1, 3, 5. Yes, 1, 3, 5 tribromo, right? 1, 3, 5 tribromo benzene. Now on which all positions it is there? This is in the one meta position, another bromine atom in another meta position. So it is called as sim tribromo benzene. Okay, it is symmetric, right? So it is called as sim tribromo benzene. Now moving on to the next one, CH3 CHCl2. It is common name is ethylene chloride or geminal dihalide. Now, why it is called as a geminal dihalide? Both the halogen atoms are present on the same carbon atom. Then we call it as a geminal dihalide. Now, IUPAC nomenclature, let's see. CH3, CH, and you have 2Cl on the same carbon atom. So, how do we name it? Okay, it will be first carbon atom, this is second carbon atom. So, 1, 1. The chlorine atoms are present on the same carbon atom. So, it is 1, 1 dichloro and ethane, right? It is only 2 carbon atoms, that is the principal chain. So, it is ethane. The next one is CH2Cl, CH2Cl. So, here itself we can tell it comes under which classification? One chlorine atom is in this carbon atom, another chlorine atom is in the adjacent carbon atom. So, this is called as vicinal dihalide, right? It is called as vicinal dihalide. And how do you write the IUPAC nomenclature? On the first carbon atom you have one chloro, second you have another chloro. So, it is 1, 2 dichloroethane itself, right? 1, 2 dichloroethane. So, I hope it is clear. So, that is with the nomenclature of the haloalkanes and haloarenes. So, I hope it is clear. So, when common name comes, you have to use the word root and attach a while halide to it. And if it is the IUPAC nomenclature, it comes as haloalkane or haloarene. Okay. And the positions or the numbers have to be mentioned on which position or which carbon atom the halogens and other substituents are attached. In common names, we can use ortho, para, meta, etc. I hope it is clear. Now, moving on to the next one, the nature of carbon-halogen bond. So, halogen, which is X, the X stands for halogen, fluorine, chlorine, bromine, iodine. It is more electronegative than carbon. So, carbon-halogen bond is polar bond. It is polar bond because there is an electronegativity difference there. So, if I am considering hydrogen and hydrogen, okay, there is no electronegativity difference. They are both the same atoms. So, in that case, there is no electronegativity difference. It is a non-polar bond. But in this case, when we are talking about haloalkanes and haloarenes, it is between a carbon and a halogen atom, right? So, carbon is less negative compared to the halogens. So, halogens will be more electronegative. Hence, a less electronegative and more electronegative element is present means there will be an electronegativity difference. Hence, it is called as a polar bond. So, your carbon-halogen bond present in haloalkanes and haloarenes is a polar bond. I hope it is clear. Now, because of that, this shared pair of electrons, what is electronegativity? It is a tendency of an element to attract the shared pair of electrons towards itself. So, this shared pair of electrons you can see here, what happens as the halogen is more electronegative, it will attract the shared pair of electrons towards itself and the halogen will get a partial negative charge. That is what is shown here. It will get a partial negative charge and the carbon atom will get a partial positive charge. Okay. Now, the size of halogens is in the order fluorine, chlorine, bromine, iodine. So, which is having the highest size among all the halogens, which is the order? When we move down the group, fluorine, chlorine, bromine, iodine. As we move down the group, the number of shells increases. Hence, of course, the size of the halogen or size of the atom also increases. Now, the carbon-halogen bond length is in the order. Now, which will have the highest bond length? Then, of course, carbon-iodine will have the highest bond length, right? Iodine is having the highest size. So, carbon-iodine bond will be the largest, right? So, the bond length order will be Ci, CCl and Cf. Okay. So, I hope it is clear. Right. Now, moving on to the methods of preparation of haloalkanes. This is very, very important. So, the first method is from alcohols. So, how we can prepare haloalkanes from alcohols? So, there are few methods. So, the first method from which how you can prepare a haloalkane from an alcohol itself, it is using halogen acid. Now, what is halogen acid? When alcohols are heated with halogen acids like HCl, HBr, HI, halogen acid. Okay, that means a halogen will be present and a hydrogen atom will be present. So, that is called as a halogen acid, right? You know that HCl is an acid, right? So, this is called as an halogen acid because a halogen is present there. So, what happens when alcohols we are heating it with halogen acids in the presence of anhydrous zinc chloride. Anhydrous means without water, okay? Anhydrous zinc chloride, alkyl halides are obtained. Now, what are alkyl halides? Alkyl halides are haloalkanes itself. So, let's see. This is ROH. R stands for any alkyl group. Okay. R stands for any alkyl group to which we add a halogen acid. Halogen acid in presence of anhydrous zinc chloride, we'll get RX instead of ROH. What did we get? RX. Now, what is RX? It is alkyl halide. Right. That is our haloalkane and water. So, let's take an example. Instead of RH, instead of R, let me take the methyl group. So this is methanol, right? This is methanol, to which let me add HCl. HCl is an halogen acid, right? In presence of anhydrous zinc chloride, what happens here? We'll get RX, that is alkyl halide, which is the halogen here. So this Cl will get attached with the methyl group. So I'll get CH3Cl. Now what is left behind? OH is there and H is there. H and OH together will give you water. So I hope it is clear. So this is a simple method of preparation, that is using halogen acids. An alcohol will be there, halogen acid will be there. Halogen acid means HCl, HBr, whichever halogen based on that, okay? And in presence of anhydrous zinc chloride, what will happen? The methyl and the halogen will combine and form alkyl halide, and water will be formed as a byproduct. Now, alkyl chlorides are obtained by treating alcohols with dry HCl in the presence of anhydrous zinc chloride, which is a dehydrating agent. Now, what is dehydration means? It will take up water, right? So, this reaction is called Grove's process. So, this name is also important. It is called as Grove's process, that is forming of haloalkane using halogen acid. The mixture of HCl and anhydrous zinc chloride is called as Lucas reagent. So, this is very, very important. So, the question can be, what is Lucas reagent? So, you need to know what is Lucas reagent, and question can be, which reagent is used in preparation of haloalkanes from alcohols. So, you need to know the mixture of halogen acid, which is HCl, and anhydrous zinc chloride. HCl and anhydrous zinc chloride, this mixture is called as Lucas reagent. Okay, so why zinc chloride is used, that is also an important, because it is a dehydrating agent. Clear? Now moving on to the next method, that is using phosphorus halides. Using phosphorus halides. This also is a preparation under alcohols itself, right? So when alcohol is treated with phosphorus halide, alkyl halide is formed. So with phosphorus penta, so now what we are going to use here, phosphorus halide. So in that itself you have two methods of preparation. First one is with phosphorus pentachloride. What is phosphorus pentachloride? Phosphorus is there P. Pentachloride means Cl5, PCl5. Okay. So chloroalkanes is obtained. Chloroalkanes we are telling, because what we are using PCl5, right? So which is the halogen present here? It will be chlorine itself. So which haloalkane will be formed? Of course, chloroalkane will be formed. Is obtained by treating alcohol with phosphorus pentachloride. So this is your alcohol. When it reacts with PCl5, that is phosphorus pentachloride, what happens? Haloalkane is formed, POCl3 is formed, and HCl is formed. So it is important to remember the byproducts as well. So what is formed here? POCl3 and HCl is formed. So let's take an example again. C2H5OH. What is C2H5OH? It is methanol, right? So let's take an example of C2H5OH. What is C2H5OH? It is ethanol, right? 2 carbon atoms, so it is ethanol. When it reacts with PCl5, what do you get? Which is the alkyl group here? C2H5, and instead of OH, Cl will be attached there, right? So now which is a haloalkane obtained? It is chloroethane, right? Chloroethane, and which will be the byproduct? It will be POCl3 and HCl. So this is the next method. Now this is PCl5. Now in the next method we are going to use PCl3, that is with the phosphorus trihalide. Haloalkanes are obtained when primary alcohols are treated with phosphorus trihalide. So before it was PCl5, now we are going to use PCl3. Okay, so 3 moles of alcohol when reacts with PCl3. Okay, when it reacts with PCl3, we get 3 moles of haloalkane and H3PO3. So it is written X here. It can be chlorine as well as bromine. So let's take an example. 3 moles of CH3OH when it reacts with, let's take PCl3. Okay, that is phosphorus trihalide. What will happen? You will get 3 moles of CH3Cl, alkyl halide. Which alkyl halide? It is methyl halide. What is the IUPAC name? It will be chloromethane, right? And you will get H3PO3. Okay, so to balance it, we are using this 3 moles and 3 moles here. So I hope it is clear. Moving on to the next one, bromohaloalkanes are obtained by reaction of alcohols with a mixture of red phosphorus and bromine. So in this particular method, we can only use the halogens, which is chlorine and bromine. So if you want to obtain bromine specifically, bromohaloalkanes we can obtain by reacting alcohols with a mixture of red phosphorus and bromine. So as you can see here, alcohol in presence of red phosphorus and the particular halogen, what you will get? You will get the particular alkyl halide. So let's take CH3OH itself. When reacts with red phosphorus in presence of bromine, what will you get? You will get CH3Br. Okay. So this is another method to obtain bromoalkane. Right. Now moving on to the next one, that is the third method, that is using thionyl chloride from alcohol. The next method is using thionyl chloride. So alkyl chloride can be obtained by heating alcohol with thionyl chloride in the presence of pyridine as catalyst. So this is a very important equation. So why it is important? Let's see. Alcohol, when it reacts with SOCl2, SOCl2 is called as thionyl chloride in presence of pyridine. So the catalyst is also very important to be remembered. What you will get? Alkyl halide, then SO2 gas and HCl gas. So SO2 and HCl, both of them are gases. So this is the importance of this reaction. So till now, what and all reactions we have covered, that is the method of preparation of haloalkanes from alcohols. 3-4 reactions we have studied. Out of all of that, this one is the most preferred reaction because in this reaction, the byproducts which are formed is SO2 and HCl. Both of them are gas. So once the byproduct is formed, they themselves will be escaped. That is because both of them are in gaseous phase. They will escape. So it will become easy for the purification and obtaining the alkyl halide. It will be easy. So this is a very important part to be remembered, because why the thionyl chloride preparation is preferred is because SO2 and HCl are gases and they will be escaping. So let's take an example. CH3OH methanol reacts with thionyl chloride in presence of pyridine. What happens? It will form CH3Cl, then it will form SO2 and it will form HCl. As these both are in gaseous phase, it will escape by itself and it will help in the purification faster. Clear? Now moving on to the next method, which is called as halogen exchange method. So till now the methods we have discussed, all of that comes under from alcohols, right? From alcohols, which all methods we can use. So the first method was using halogen acids from using zinc chloride and has anhydrous zinc chloride in presence of that, right? And next one is phosphorus halides, PCl3 as well as PCl5. Okay, so the byproducts are also important to be remembered, and the next one was from thionyl chloride. So all of this was from alcohols. Now moving on to the next one, halogen exchange method. So from the name itself you can say there will be an exchange of halogen which is going to take place. So the first method is called as Finkelstein reaction. So alkyl iodides are prepared by the reaction of alkyl chloride or bromide with sodium iodide in dry acetone. So this reaction is called as Finkelstein reaction. So Finkelstein reaction helps in the formation of specifically which alkyl halide or which haloalkane? It will be iodide, right? Alkyl iodide we can prepare. Okay, Finkelstein reaction, we can prepare alkyl iodide from alkyl chloride or alkyl bromide. Okay, so let's take an example, RX, that is CH3Cl, let's take. So in this case, it's not alcohol, already from a haloalkane, we are going to prepare another haloalkane. Okay, so haloalkane, I'm going to take chloromethane here in presence of sodium iodide and dry acetone. In the presence of dry acetone, what happens? An exchange of halogen will take place. That means the iodine will be attached here. So you will get methyl iodide, and what is left behind? Sodium and chlorine, and it will form sodium chloride. So I hope it is clear. So instead of chlorine, it can be bromine also, CH3Br, bromomethane also, in presence of sodium iodide, dry acetone. What will happen? You will get CH3I, iodomethane, and sodium chloride sodium bromide will be formed, right? Now sodium chloride or sodium bromide thus formed is precipitated in dry acetone. It facilitates the forward reaction. Okay, it will be precipitated in this reaction. Okay, sodium chloride, sodium bromide, these are salts, right? They will be precipitated in the reaction. So this is called as Finkelstein reaction. It is used for the preparation of specifically alkyl iodides from alkyl chloride or alkyl bromide, which is a reagent used sodium iodide in presence of dry acetone. Now the next method is Schwarz reaction. Now, this is used for the preparation of alkyl fluoride. Okay, Finkelstein for alkyl iodide, Schwarz reaction for alkyl fluoride. Okay, so alkyl fluorides are prepared by heating alkyl chloride or bromide in the presence of a metallic fluoride such as silver fluoride or mercuric fluoride, etc. The reaction is termed as Schwarz reaction. Okay, so what is happening here? We can take an alkyl bromide or alkyl chloride, reacts with silver fluoride or any metallic fluoride. That means a fluorine will be there, a metal will be there associated with it. Okay, so what will happen? There will be an exchange of halogen and you will get alkyl fluoride and the metal and the bromide together. So let's take CH3Cl here. Alkyl chloride also we can prepare, right? So silver fluoride is taken. There will be an exchange happening here. Fluoride will go to the methyl. So you will get methyl fluoride, that is alkyl fluoride, and silver chloride will be formed. Okay, based on whether chlorine or bromine is taken, alkyl silver bromide or silver chloride will be formed. So this is how an exchange of halogen is taking place. That is why these two methods are called as halogen exchange method. Right. Now the next one is by free radical halogenation. By free radical halogenation. Free radical chlorination or bromination of alkanes gives a complex mixture of haloalkanes. So what does that mean? CH3, CH2, CH2, CH3. Which is this alkane? This is butane, right? So in what we are going to do? We are going to add chlorine or halogen, any halogen. Halogenation means what? Addition of halogen. So here we are going to add chlorine, which is the mechanism which follows. It is called as free radical mechanism. So it happens in presence of UV light or heat. What will happen? CH3, CH2, CH2, Cl. So instead of one hydrogen atom, what happens? A chlorine will be attached. So another product that can be formed is on the second carbon atom, a chlorine can be attached. So in this case, what happens? A complex mixture of haloalkanes can be obtained using free radical mechanism. Right, chlorine atom is being added, so it can be obtained on any carbon atom. So what happens here? So in this case, 4 carbon atoms are there. So either it can attach on the first carbon atom or the second carbon atom. From this direction also, if we take it, this will be the first carbon atom, which is of course the same product itself, or it can come in the second carbon atom, which is of course the same product. So only 2 possibilities are there, right? So this will happen according to free radical mechanism. So I hope it is clear. So in the next session, we are going to study about the physical and chemical properties of haloalkanes and haloarenes. So under chemical properties, there are various chemical reactions that we are going to study, which are very, very important. So I hope the concepts that we have covered in this session is clear for you. So that's all for today. Thank you.